Hello, welcome back. In today's lesson, I'm going to show you how to do a few things. First, I'm going to show you how to step into calls. Second, how to write a script that does not insert any jump into code caves, but instead directly patch memory with bytes. So let's get started. So this is a new CrackMes called G's. When we run it, you can enter any username and serial key, click register, and it gives you have entered invalid data, bad message. Alright, so now I'm going to show you another way to look for the address in memory. In the previous lessons, I showed you how to scan for memory in here. Now I'll show you another way. We use reference string method. So first we attach to this CrackMes, and then now when we click register, we see this bad message. So we are going to use a reference string method. Click on memory view, and then here go to under view, scroll down and look for reference strings. So just click on it. This will search all the strings that are used in this program. So click on this, and it will say you need to run the dissect code routine first. So we click yes. Okay, so now it has scanned this program for all the reference strings, and you find this string is found here. You've entered invalid data and the address is over here. And then you will also see other interesting messages: success, registration successful. Okay, so you have 4 interesting strings here. Alright, so now we want to go to this address for this string. So double click on this and you go straight to the code. And here is where the bad message is being created. And this is the message box which you see here. And then if you look down, you will see the good message and the message box as well. So if you scroll up, you will see the jump. And this jumps over this message to show the good message. If it does not jump, it will show a good message. So now let's put a breakpoint and see what happens here. We know that it did not jump because of the bad message coming from here. But let's go and just analyze it. Let's put a breakpoint here, right click, set breakpoint, click OK, click yes, and then click OK here. Now we click the button register and it hits our breakpoint. Okay, let's step over. So when you step over, it did not jump. It did not jump, instead it went inside. So step over, and now it's pushing the bad messages to the stack in preparation for this message box. So when I step over the message box call, the bad message has been shown. You have entered invalid data. Okay, so in this case, we want to jump. We want to assemble this to become a unconditional jump. At the moment, this jump is conditional because the jump takes place because of the test here. So if the test here, if EX is 0, then the jump will not take place. It will only jump if not equal. That means if EX is not equal to 0. But in this case, because EX is 0, that's why it did not jump. Okay, so this is the meaning of test EX. Test EX will determine whether or not to jump. So in this case here, because EX is 0, therefore it did not jump. Instead, it went here. So to make sure that it jumps, one way to solve this is to assemble, right-click assemble, and then, but we can assemble, we have to toggle breakpoint first to turn off the breakpoint. Then we can assemble, right-click, assemble, and now we are going to convert this JNE to become a JMP. JMP. Click OK. And now it becomes a unconditional jump. That means if we jump, doesn't matter the value of EX, it will jump. Alright? So now we can put if we want to undo this, we right click, click assemble, and then change it back to JNE. Click OK. See that? Here is how we undo the changes we make. Alright. So before we assemble a jump, let us first right click and add to the code list. Click OK. So click OK again. So when we add to the code list, we have under advanced option, we can see it here. This is something like a notepad, keeping track of all the interesting addresses. Okay, right. So now we are going to assemble a jump. Right click on this, assemble, and change this to JMP. Now one thing to be careful is to note how many bytes are here. This JNE instruction takes up 2 bytes. So if you are going to change this to a JMP, make sure it also takes 2 bytes. Because if it exceeds 2 bytes, it will overwrite the instruction below it, and that might cause the program to crash or whatever. So click OK, and you see it only takes up 2 bytes. So it's okay. So now if we were to run this and then we click register, we get a good message. Why? Because it jumped down here. So this is how you can crack this particular program to make it show the good message. Alright, this is one way to solve it. If you click OK, the program will quit like that. Alright, so this particular program quits when you show the good message. So let's try again. Run it one more time, and let's reattach to the program. We close this assembly window, attach to it again. Click yes. Alright, so now we can click advanced option and go back to our code list and double click this to show us the location where we previously analyzed. So now we can easily do a inject code to convert this to a JMP. We can click tools to assemble, and then template. It will be injection. Okay, okay, and now over here we want to convert this into a JMP. First we comment out this one, then we copy this and put it here. Then we convert this to a JMP. Then we click File, Assign to Current Cheat Table, like that. Alright, so now we have it here, and we can give it a name. We can call this JMP, like that. So now if we click on this, before we click on this, we just check one more time our program. Just enter anything, register, and we get a bad message. Okay, so now we activate our script and see what happens here. it becomes a unconditional jump. And now if we click on this, we get a good message. Click OK and then program quiz. Okay, so it's working. So this is one way to solve it. Now I'll show you another way to solve it. We can close this now. Run our CrackMes again. Attach to it. Click yes. Click yes. Alright, another way to solve it. Let's go back to the here, advanced option, go back to this code. Okay, another way to solve it is to step into this call, because this is a call which sets the value of EX. Now it is a principle in assembly language that after a call, the result will be stored in EX register. That is normally the case. So whenever you see a call, the call will store the result in EX. This call also will store the result in EX. So in order to find out what sets the value of EX here, we must step into this call. So we can put a breakpoint here, toggle breakpoint in this call, and then we can step into it to see what sets the value of EX to become 0. So now we can run. After entering something, we click register and it will hit our call here. See that? So now we click step into and we're now inside the call. Now we click step over and examine keep an eye on the EX register to see when it becomes 0. Step over. Keep your eye here, watch this. Now it's 4. Oh, now it becomes 0. See that? So it became 0 because of this instruction. Move EBX to EX. And EBX was set to become 0. So we can make a comment here. So we can double click here and put a comment. We can say that EBX register, the content of EBX was copied to EX over here. And we know that EX is 0, therefore EBX must be 0. So now we want to know what sets EBX to 0. We go to the instruction just before it. And this is where EBX became 0. So EBX became 0 here. So we make a comment there as well. Okay, so we have our comments. And after we add our comment, we can put a bookmark. So we right click this, set bookmark. And there are a few bookmarks we can set, 9 locations. So we just put in here, bookmark. So that in future, if you want to go to a bookmark, we just have to right click, go to bookmark and select the bookmark that you want to go to. And we come back here. Alright, so how do we know that EBX became 0 here? Because XOR EBX is the instruction which sets it to 0. Whenever you XOR any register with this cell, the register becomes 0. That is how XOR works. So in this case here, if we don't want EBX to become 0, we can do this. Right click, assemble, change this XOR to become OR. So whenever you OR any register with this cell, you maintain its original value. So this is how you reverse an XOR. Okay, so we are going to use the code injection to do this. Alright, so we select this line here now, toggle the breakpoint. I think we can leave the toggle alone. We click on tools, go to auto assemble, template, AOB injection. Click OK, click OK. Alright. Now we can just delete all the comments. We don't need it. Now, this time, instead of injecting in the code cave, we are going to overwrite this one directly. Alright. So, this code 31db refers to XOR. We want to know what is the bytes for OR. So we can just find out by right clicking here, assemble. Now before we do that, we just copy these bytes. Right click, copy the clipboard, bytes. And then we can come here, table extras, and paste here. So this is a notepad for us to write our notes. Okay, so now we know that the original bytes is 31 dB. Okay, so now if we were to assemble an OR here, just try and see. 31 dB became 09 dB, right? So we can just copy this now to clipboard and then come back here and paste it below. Paste. Alright, so 31 dB is XOR and 09 dB is OR. Okay, remember that. So now let's undo this, put it back to XOR. So we are going to use our script to do it. Alright, so instead of doing it in the code cave, we are going to directly overwrite this part in memory. So we can do that like this. We don't need to allocate memory. We don't need this. We don't need this. All this we don't need. We can delete it. And then here, this inject here refers to this location. Alright, so we can move our register symbol to the top. And then this part we don't need to return also. We don't need this jump also. We can just delete this. Instead, we will directly write our, let's go refer to the table extra. We can directly write 31 to this location. Sorry, we can write 09 to this location. Okay, 09 is OR, remember? So we put 09. And if you want, you can even put dB at the back, but it's not necessary, right? But I'll put it anyway. So now, after we finish injecting, when we disable it, it will copy back 31 to here, right? When we inject, we put 09 here, so that this will become OR. When we finish, we disable the script, it will restore back 31 here. So all you need to do is actually, we can remove this. Alright, so when we inject, we put 09 in to replace 31. When we restore, we put back 31 here. So this is the meaning of this line. DB means declare bytes. I think I explained this before. When you declare bytes, it means you are directly changing the value of the bytes in memory directly. Alright, so we also don't need this. So our code now is very short here. When this thing runs, it will scan for this pattern in memory. When you find this pattern in memory, 31 dB, 89, D8 and so on, it will go and overwrite these two bytes with this 09 in D8. And then we can even shorten it further. 09. Overwrite 31 with 09. And then here, when we disable this script, it will restore back with 31. So we can just delete the back if you don't want. Even shorter. Okay? So our code is very short. And then normally, as a convention, we put here +0. +0 means offset 0. sometimes we want to write in different location, so we might do something like this. If we have multiple bytes to write, we will do something like this. At position 0, offset 1, we might declare something else, db maybe 2, 3 or something. Right? So when we did this, plus 1 means at position offset 1 will be db, we want to write 23. At offset 0, we are going to write 09. So this is the meaning of plus 1. And then we can keep on going and on and on and on. For example, we can put offset 2. Offset 2, we could write something else, maybe 5, 6 or whatever we want. So inject plus offset 0 is referring to 31, and we want to write 09. Inject plus 1, offset 1 here, that means we want to write 23 at this location. Inject plus 2 means this location, offset 2, and offset 2 we want to write 56. This is the meaning of plus 0, plus 1, plus 2, okay? Plus 0 means here, plus 1 means here, plus 2 means here. So this is direct tampering of memory, okay? So just to let you know, but in this case, we don't need to write all this, we can just delete this. We only need to directly write to this location. So it is always a good idea to put plus 0, so that we know that we are referring to offset 0, which is here. Okay, so inject refers to this memory address. Alright, so inject is registered here to refer to this memory address. Alright, so now we can assign this to the current cheat table and close it. So now we have it here. I think we forgot to assign. Oh yeah, we did. Alright, so we assigned it to our cheat table, and then now for the second one, we're going to call it db to differentiate with the rest one, with the first one. Okay. Alright, so now watch what happens when we activate this. Watch this. See that? It became 09. Alright? Why? Because our script wrote 09 to that location. Now watch what happens when we deactivate it. It became back to 31. Right? Why? Because when we deactivate, it writes 31 to that location. Okay? So this is directly writing to memory without injecting code. Alright? We are not injecting any code. We are directly overwriting memory. Okay, so this technique is different from the earlier techniques. This one here, we are injecting code into the code cave. This one here, we are directly overwriting memory. Okay, so two different techniques here. This one is code injection. This one is direct memory access. Alright, so now we are going to test the second one. Let's run our program, and now if we click register, it shows the bad message, right? Alright, let's activate this one. Alright, let's run all the way, and we should see our good message. There you go. Alright, so in this lesson you learned quite a lot of things, some advanced techniques, and go and review this video again if you did not understand anything, and you should be okay. So be sure to save this cheat table, and we are going to call it GCT. Okay, just GCT will do. Save. Alright, that's all for this lesson. Thank you very much for watching.